Hello everyone. Welcome back to Edututorials by KatRidge, where we make learning simple and help you succeed in your exams. That's the motive, right? That's the motive. So my name is KatRidge, and today we're continuing with our grade 10 mathematics series with lesson 2, Laws of Exponents. We're still continuing on the Laws of Exponents. If you haven't watched lesson 1, I recommend you watching it first because we build up on what we have already done. So I hope you watch it and like it and share it amongst your friends. So yeah, by the end of today's lesson, you'll be able to apply the laws of exponents correctly, simplify exponential expressions, avoid common mistakes that are being done in the exams. So we carry on with what we have already know. So let's see. By the end of the lesson, you should be able to multiply the powers with the same base, divide powers with the same base, raise powers to another power. I think what is here, we have already done some parts of this lesson, so we're gonna keep it brief. We're gonna keep it simple so that you can understand. And there's an important notice that I'd like to share with you guys. At the end of each topic, we're gonna try to attempt the exam questions and see how we build up from that. So yeah, we're gonna attempt many question papers so that we can become much better, much better. And today we're gonna understand zero and the negative exponents. So we are building, guys, we are building. So don't be shy or something. Don't be shy. Okay, you remember that if you multiply numbers with the same base, this is what you're gonna end up with. So here I'm saying a squared times a squared. Basically, what we're gonna do here, we're gonna say a to the exponent 2 plus 2, and we're gonna end up with a to the power 4. We're just recapping, guys. We're just recapping. That's rule number 1. That's rule number 1. And rule number 2, what we are doing, we just divide powers with the same base. What we are gonna do, we subtract the exponents. So here is how it goes. 3 divide by a to the power 1. What we're gonna end up with here, we're gonna say a to the exponent 3 minus 1, and we ultimately end up with a to the exponent 2. That's rule number 2. When dividing the powers with the same base, you subtract their exponents. So that's how it goes, man. That's how it goes. And we're just recapping, guys. We're just recapping. And then power of a power. Power of a power. Rule 3. Power of a power. It goes like this. To the exponent 3 to the exponent 4, maybe. Okay, to the exponent 4. Basically, what we're gonna do here, we're gonna multiply the exponents. The exponents, meaning it will be like this. A to the exponent 3 times 4, which will give us a to the exponent 12. See how easy it is? See how easy it is? So I hope you try as many examples as you can. So rule 4, what it states is that we any non-zero number raised to a power of a 0 equals to 1. This is what it states. This is what it states. That any number that is non-zero number raised to a power of 0, that number will equal to 1. No, regardless of how big that number is. For example, I'm going to take 100 to the power of 0. Sorry, to the power of 0. What this will equal to? It will equal to a 1, regardless of how big that number is. You're going to end up with 1, regardless of what that number is. I hope you remember that. I hope you remember that. So, rule 5, we are talking about the negative exponent. Negative exponent means you take the reciprocal of that number. Here, for an example, if I take 2 to the exponent negative 3, what it states is reciprocal of that number that you are given is going to be 1 over 2 to the exponent 3. And ultimately, you're going to end up with 1 over 8. That's what it states. And then another example, we're going to have 10 to the exponent negative 2. What it states is that it's 1 over 10 to the exponent 2. Ultimately, you end up with 1 over 100. This is how simple it is, guys. This is how simple it is. And we are carrying on, and I hope you take as many examples so that you can become much better. So you can become much better. So, common mistakes that learners do in the exams or in the classworks when they try to attempt to do laws of exponents. They tend to add exponents when dividing, and that is totally wrong. When we divide the exponent, when we divide the base with the same number, we subtract the exponent. Another one, multiplying the exponents with when multiplying exponents when multiplying. You don't multiply, you add the exponent. And that, forgetting that any number to the power of 0 is 1. Any number. Infinity to power 0 is 1. Regardless of how big that number is. And another one is that they forget to write the reciprocal for a negative exponent. We tend to forget that we need to write the reciprocal of that number when we deal with negative exponents. Again, guys, always check which law you are using before simplifying your problem. So I hope you don't do these mistakes ever again after this lesson. You'll know what is what what to do and what not to do, right? So yeah, guys. Okay, let's try to attempt another worked example. Work with me. We take 4 to the exponent 2 multiply by 4 to the exponent 5. I hope from here we know, guys. 4 to the power of 2 plus 5. Ultimately, we end up with 4 to the exponent 7, right? End up to the 4 to the power of 7. That's how it goes. Okay, let's try another one with division, right? Take 7 to the power of 8, divide by 7 to the power of 3, which will equal to 7 to the power of 8 minus 3. You end up with 7 to the power of how much? 5. Yeah. So you see how easy they are. And we're gonna take example of power of a power, which will be like 3 to the 2 to the exponent 3, close bracket, 2 outside, which is the power of a power. So what we're gonna do here, we're gonna say 2 to the exponent 3. Why I keep saying 3 to the exponent? It's 2 to the exponent of 3 plus, no, it's not plus, guys, it's not plus, sorry for that, sorry, it's time is, sorry, what am I doing? What am I doing? Sorry, guys, sorry. Time is 2, which will end up with 2 to the exponent of 6. See how it goes. See how it goes. It's so easy, né? It's so easy. Let's try a negative exponent problem. We're gonna take 5 to the exponent negative 2. We're gonna say 1 over 5. They said we need to take the reciprocal of that number. So 1 over 5 to the power of 2, which will ultimately equal to 1 over 25. Then we carry on and see how you attempt to do some of the questions with me here. Ne? And if you want to try them on your own, you can pause the video and solve these questions. So yeah, guys, it's so nice to be delivering these lessons to you, and it's so nice, man. It's so nice. It's first time I have ever done this, so bear with me, guys, bear with me. There'll be glitches there and there, but we carry on, man. We carry on. So we can take another example. 3 to the power of 2 times 3 to the power of 5. Ultimately we be with 2 plus 5, which will give us 3 to the power of 7. See how easy it is. And I'm gonna take one example each rule, ne, to save time, and so that you cannot get bored over this video, so that it's too long and it's boring. So yeah, let's take another example. To the power of 2. 6 to the power of 7 divided by 6 to the power of 2. We're gonna have 6, 7 minus 2, which will ultimately be 6 to the power of 5. Okay, let's take another one. 4 to the exponent of 2, close bracket. Power of that exponent is going to be 4 to the 2 times 3, which will end up with 6. 2 times 3 is 6. So yes, guys, I hope you see it. For a number with power of 0 that will equal to 1 eventually. Let's take any number that we like. What are you thinking about? 20 maybe? 10? Okay, let's take 20. 20 to the power of 0 will equal to 1. I've said regardless of how big that number is, it will equal to 1. Only if that number is to a power of 0. So let's take another example. 2 to the exponent of 4. Sorry. To the power of -4. Sorry. We're gonna have 1 over 2 to the power of 4. Sorry. This pen is playing with me. To the power of 4. It's 4, man. It's 4. So yeah. We're gonna ultimately end up with that number, and which will give us 2 to the power of how much? How much is that number? 16, right? 16. So we carry on, guys. We carry on. I hope you practice these questions, and you can use past exam question papers, your textbook, any sourceful piece that can help you to achieve or understand better. You can use any source, guys. You'll get this right. So I hope, guys, you now able to apply the laws of exponents correctly, simplify exponential expressions, and solve exponent problems in examination. I hope we can try to attempt that in the near future and see how it goes. So excellent work, man. Excellent work. Today we have learned 5 main laws of exponents and how to apply them to solve mathematical problems. If you have found this lesson helpful, please like the video, subscribe to Edututorials by KatRidge, and turn on the notification bell so you don't miss our next lesson. And in lesson 3, guys, we'll explore surds, irrational numbers, another important grade 10 topic. I hope I catch you guys and see you in the next one. Basically, we are done with the exponents, and I think we're gonna try to attempt the exam question before lesson 3, which will be surds and irrational numbers. So I think we're done, and thank you so much, man. Thank you so much. Don't forget to subscribe, like, and share amongst your friends, you with your teacher or with your classmates. So thank you, guys, and I love you, man. See you in the next one.